have an overview, what exactly is explainable AI, why do we need it, and how can you incorporate small methods or basic projects in your own working or anything you're doing, or whenever you come across a new blog on explainable AI, you would be able to grasp the basic knowledge after reading it, right? So before I start, there's something about me. I'm a second year doctoral researcher student at SFI Center ML Lab. We have other PhD students here with us. So, and I'm currently working with Dr. Luca Longo at TU Dublin, right? So today we'll discuss the concept of explainable AI. We'll try and understand what is the concept of right to explanation according to the GDPR rules. We'll try and understand why exactly there is a need for explainable AI. We'll discuss the basic taxonomies and the basic words or approaches that you should be knowing when you are digging in this domain. And we'll have a very basic overview of the SHAP as an XCI method, which is a very popular method these days. And I'll not discuss any maths about it, just basic understanding, right? So, I would like to keep this session in a very interactive manner. So, you are free to say anything, whatever comes in your mind, any doubts or anything. So, let us see this image. How do you interpret this image? Like, anyone would like to say what is coming in your mind when you read this? Yeah.
Mix it all up in the learning stage.
Yes.
So that eventually you pop out some sort of model. Right there you have like a neural network.
Yeah.
But that model has a bunch of weird model weights that like, what are they doing? I don't know what they're doing. But hey, it predicts, does good outcome, right?
Yeah.
Yeah. And so, but maybe we would like to know what the model weights are doing. Like, is there a reason that this one is 0.3?
Yeah.
Yeah.
Yes, so this was a very basic understanding we could get. For example, you are talking to your Alexa and Alexa gives you some abstract reply or like a witty reply and you don't know how come Alexa gave you such a reply. So you don't know how the model is working, what is the inner working. So in order to understand those concepts, apart from your basic machine learning and deep learning model, another domain was introduced, like although it was introduced in late 80s, but suddenly people started studying about it again, like from past 3 or 4 years. There has been a good search and publication. So whenever we are trying to understand how exactly the model gave some results to us, that domain would be defined as explainable AI, right? So let's go further. We'll take a small case study. Let's say there's a person named as Sarah. She applied for bank loan application at Bank of Ireland, and the Bank of Ireland was working with some third-party organization to build their ML models for them. And what happened was Sarah's loan application was rejected. Now, neither the Bank of Ireland had an explanation, nor Sarah had a proper explanation that why her application was rejected. Now, the Bank of Ireland went to the third-party company who was building the model application for them and they asked, can you give us some application? Or can you give us some reason that why exactly the loan was rejected for Sarah? Now, here comes the role of the developers, all the Python developers, all the people who are doing coding, machine learning, to apply some explainable AI methods over the machine learning or the deep learning methods they have used to give the decisions to Sarah that was her application rejected or accepted, to understand why it was rejected. Now, there would be different XAI methods that a developer or a coder would be using. Now, to understand what are these different XAI methods, in what different situations they would be used, this is what we are going to discuss as the XAI methods, or you can say as the XAI taxonomy, right? So, this is just one basic audience understanding image, so that if you were not able to grasp my example, you can take few seconds, read through this image and you can get through. If it's not readable, so it's just something like we had some training data, we trained the data, we passed the training set, test set, and we used, suppose, a CNN. And we got some values, some results, or the probability value. Let's say it would predict that from this image we had a car, right? Now, okay, a user said, okay, it was a car, but how did you exactly tell it was a car? So, above all this training, we applied some explainable model. It gave us some explanation in form of texts, like, okay, and now a person or the end user of the application was, okay, fine, I've got some explanation to a certain extent, and okay, he says, I understand. This is just a very basic example so that now when you go out of this room, you know what exactly is explainable AI, right? Or you can just tell people with some basic examples. Now, we all know we have certain rights as human beings, right to food, right to study, right to living, etc., etc. Now, with the growing digital age, we also have right to an explanation. If you are aware, the European Parliament is working on the AI Acts. I'm not pretty sure about the fact. I think some document came out few days back on AI ethics and responsibility. As a part of it, the European Parliament and Council have introduced the GDPR rules, that is called as the General Data Protection Regulation. And this just says that as a person, you have a right to ask any organization that why you got certain results, why your loan was rejected, why the female application was rejected from your job application stuff. If you remember that Amazon case, like Amazon was hiring more of males as compared to females, like there have been so much biases. So in that scenario, they have introduced this right to explanation. And if you're working on current projects in your companies, maybe in few months or in next few years, there would be a certain team that would be working on this part on your projects. And even in the PhD, now every person is required to add the explainability along with the projects. Now, there are two terms that are often used like interchangeably. There are a lot of terms in this explainable AI domain. There are no distinct boundaries right now. So there are two terms that is called as the interpretability and explainability. Although they can be used interchangeably, but there is still a certain boundary between these two terms, right? So when I use the term interpretability, it just adds one more definition to it, like your explanations are understood by humans, or an end human user can understand your explanation. That would be called as interpretability. And if we are just interested in knowing the inner working of the model, we are not concerned about human right now, that would be called as explainability. Or transparency, interpretability, explainability, they can be used interchangeably, but still there's a bit distinction that everyone should know. Now, there's just a basic thing we all should know. Why exactly there is a need for explainable AI today? Because we want some transparency. All the stakeholders should know that why the model's decision was in such a way. We need some fairness, right? We need some trust, and we do need some reliability. So these are the basic things, and these are all in compliance with all our GDPR rules. Although there is a big 7 list for the need of XAI according to the GDPR rules, but these are some basic things that we should all look upon when we are doing our next projects. Now, I just want you to take a look for a few minutes, and I'll keep on explaining this image. Let us say, I hope everyone is aware of the basic machine learning pipeline, right? We have some input, we pass it through the model, and we get some output, right? Right now we have discussed is that we are getting certain explanations. The explanations that we get could be in the form of text, could be formed in some numeric values, or there would be any output data type or format type that would be considering, right? Now comes the discussion on the XAI methods. XAI methods can be divided into different categories, right? When an XAI method is applied before training the model, that XAI method is called, or it falls under the category of ad hoc methods, right? Or any explainable model or explainability method is applied after training the model, then it is called as the post hoc explainability method, right? So something before training the model, any method of explainability would lie under the category of ad hoc explainability method, and something after training the model would lie under the category of post hoc explainability method. And what I work in my PhD, I work on the post hoc explainability methods, and I work for the time series data. Like when the input is as time series, I work post hoc explainability for time series data, and that too using the state transition representations. Like I use DFAs and other things to explain why a time series is giving certain results when a model is applied on it, right? So I hope everyone is clear with the distinction between the ad hoc and the post hoc category, right? So now this explainable AI methods that what we are looking today, all this category can be divided in a hierarchical form, right? So right now what we discussed is that where the explainable AI methods are used, at what stage. It was before training the model, then ad hoc. If it was after training the model, it was post hoc, right? Again, the post hoc methods can further be divided as the model agnostic or the model specific. We'll keep our discussion today till only this part. We'll not go further down below, right? Now, the explainability method could also be applied on the basis of scope. Either we need a global explanation, like for the entire model, or a local explanation regarding a specific feature or a specific point while training a model, right? Again, there would be different explainable AI methods depending upon the problem type you are working on, right? For example, if you are working on a classification problem, there would be a different explainable AI method, and if you are working on regression problems, then it would be different, right? Similarly, it depends upon the type of input data you are passing to the model. Different input data types, there could be different explainable AI methods. And similarly, if you are aiming or looking at the output of your model, if you have different outputs that you feel you want to get some visual output or you want to get some mixed output, then you can apply the explainable AI methods in that category, right? You might be feeling, okay, all seems the same, but these are the just different scopes or things. Yes. So different people may treat their problems according to the different scenario, and they can use the explainable AI methods in that way, right? Now, let us go forward and look what exactly is the distinction between the model-specific post hoc explainable methods and the model-agnostic post hoc explainable methods. I know everyone is not aware of all the jargons that I'm using right now, so I'll not go into the big details. What I'll just say is that, let's take a small note. Model-specific explanations would be the explanations only specific to the models that you are using. For example, you are using random forest. Let's take a basic ML model. I'm not going into any deep learning model right now. Let's say we are using SVM, decision tree, random forest. If an explanation is just oriented towards that model itself, then it would be a model-specific explainable method. And if we are just concerned about the whole model, like we are not concerned about any specific model, be it random forest, be it deep learning model, be it RNN, be it CNN, the model agnostic models can be applied to any kind of model, right? The only problem with the model agnostic models is that the computation becomes very difficult, right? So that's why to deal with this, you have to deal with your GPU issues, you have to deal with how big your data is. So there are other considerations that you need take into your mind, right? So but the two popular model agnostic models right now they are in the market are the SHAP and the LIME, right? So the LIME full form is Local Interpretable Model Agnostic Explanation, and SHAP we'll discuss now, so I'll leave little bit here. So I hope even if you don't know the things, you just know basic things right now. Now, as we are just discussing the taxonomy right now, all these jargons or all these words that I discussed with you, these were the basic things that everyone should know when you are discussing the explainable AI domain, right? Now, there's always a blur line between everything. Since this is a growing domain right now, people have not made any specific categories. So there's a paper that I'm following. I think I can give you the name of the author afterwards. What he has done is, he has divided all these explainable AI methods into different approaches, right? There would be like some would be common, some would be different, but all these methods can be categorized into 4 big approaches where people working on different projects can pick up an approach and say that I'm using this method for my explanation, right? So we look into 4 approaches one by one. The first approach is the functioning based approach, right? If you're feeling sleepy, it's just few more minutes. Don't feel sleepy right now. So when we are discussing about the functioning approach, the term functioning here exactly means the way the explainability method is able to extract the information from the method, right? So it's a verb and we are dealing with a verb. So it's all about extraction of information from the model, right? So I don't know how much people are aware of these jargons, but I'll just go with the basic ones. For example, you all, I think, be knowing basics about the feature engineering, right? So if you change the inputs, it may affect the outputs that you're getting, right? So this is also one of the basic things that we use in explainable AI. If you're changing the number of inputs, the feature attributes, obviously when you're applying an explainable AI method, you would get different outputs, right? So this is just one way of doing it. Another basic example I would like to take under this category would be like, obviously if you're using a post-hoc method and you're changing your model architecture before, it will affect your explainable output, right? So this is one of the categories that we would be discussing. I'll not go into the details of the others. So the first approach that we discussed was the functioning based approach, and I discussed 3 or 4 subpoints that lie between the functioning based approach, right? Now the next approach that you could analyze your project or look into would be the result based approach, right? Depending upon the result you are getting as an output from an explainable AI method would be called as a result based approach, right? So what exactly the term result means here? It means the semantics of the explanations produced, right? So again, there was a blur line. We already discussed the importance of the features. How you change the features would affect the output. Similarly, there is another thing called as the surrogate models. When you build models that are inherently understandable are called as surrogate models. Let us take a small example. I hope everyone remembers what were model agnostic methods, right? Okay. Okay. Or let us say you remember what were the and hoc methods, right? So the surrogate models can lie under the and hoc methods, we can say, right? Or let us take a small example of surrogate models. I hope some of you might have applied early stopping. while training. Even if not, you can look it afterwards. When we are doing early stopping mechanism, at each epoch we get some new models. We can say that those models are the surrogate models at some level, right? So for example, you are doing a project in a company and you are asked to choose that under what approach your explainable AI method could be used. You could identify from all these 4 approaches that we are discussing right now. So based upon the different applications that would you be using, any person, this would be the best approach, right? So I think I can give few minutes and take some water and you can read the slide. Now, one of the approach is the conceptual approach. Now, this approach is like a mix of all the things that we have studied till now. Now, conceptual approach includes the different dimensions of the explainable AI methods that we have already discussed before. So, these approaches are just a method to divide a taxonomy under 4 different categories. We already discussed these approaches separately so that we understand what each word means, right? And now when we are talking about the conceptual approach, it does include the scope where the explainable AI method is used. We have discussed it. It does discuss the stage where the explainable AI methods are applied. We have already studied about it. And we have already discussed the difference between the model specific and the model agnostic. And there would be other dimensions or scopes that would be involved. That also we have discussed. Like explainable AI method would be dependent upon the type of problem or the output that we require. Right? So this approach is best suited for example, a PhD student who has already done a good literature review. He or she knows about the basic concepts. So when I would be discussing my things with other people who are already expert in the system or my supervisor or anyone, I would say, okay, I'm looking at a conceptual approach to my problem, or I'm looking at a conceptual approach of the explainable AI methods in my project, right? So apart from all the looking at the separate meanings of the term, it is very necessary as a beginner in this domain that you understand what approach your problem lies in. Although there would be a blurred line between the approaches, but still you can like subdivide it into categories according to your own project work, right? Then again, this is, I don't know why the researchers do this when they don't know the things. They just mix all the things and call it a hybrid model. Similar approach was introduced here, right? So now a question arises. There are different researchers, there are different explainable AI methods that we discuss, but everyone categorizes them into different approaches and categories, right? For example, let us take an example of an explainable AI method that is called as counterfactual explanations. Even if you don't know the meaning, it's completely fine. Just think this is some explainable AI method. Now, after doing a literature review, some people observed or some authors said that this explainability method lies under the concept of the local explanation, right? And another author said, no, for me, the counterfactual explanations lie under the concept of the example-based explanation, right? See, method would be same, approaches would be different for different people. The categories would be different for different people. Since it is a growing domain, there is no distinct boundary, right? So if I'm saying I'm using SHAP as a feature-oriented explainable AI method, it would be fine. Someone can come under a different approach and can say it would lie under a different category. All you need is to give an explanation for an explanation here, right? So if you are reading different blogs and you feel this distinction, it's completely fine, right? So when I began my journey, I used to feel confused. Okay, some people use LIME. We are not going into the details right now. Let us say it's just one of the methods. Even I felt confused. Like some people call at this, some people call at this, but it's completely fine. As long as you know the inner working, you know how the mathematics is behind that model, you can put it under any category. You just need to have that proper understanding, right? You already know the meaning of the terms, you already know all the 4 different approaches, you just categorize them accordingly, right? And apart from it, there would be reviewers reading your work. So, now let us look what exactly SHARP is, right? SHARP, the full form is Sharply Additive Explanation. Where did this SHARP method arrive from? From the concept or the study of the game theory, right? So what happens is that we can say that SHARP is a post hoc method. So when I say post hoc, I think everyone can understand. It's a method of explainability applied after training the model, right? And it is also a model agnostic method, right? I hope few people remember what was model agnostic, right? So what are we doing with SHARP? SHARP is a method that looks into the input feature importance, right? So when I used the feature engineering term before, I was saying if I change the inputs, apply an explainable AI method, I would be getting different outputs, right? Now, similar thing SHARP is doing. What SHARP helps us to understand is that how different input features would affect the explanation that we are getting from the model, right? Let us take a very small basic example. You are in a group project, right? You are in a hackathon and you are winning a prize of like say $10,000. There's a team of 3 or 4 people, and one person is the best coder, one person was doing pair programming, one person was just drinking all the free drinks, and one person was just googling all the stuff for other person or using ChatGPT to find the results, right? Now when they get the price of $10,000, everyone fights over, right? No, I worked more, I should get more. But what happened was that the person who was having the free drinks got more money, right? So this is not fair. Similarly, this is not fair in your ML models. Each feature has different importance, right? So in order to find an explanation how different features affect your explanation, we look into the SHARP, right? Let us take a very basic scenario. Like you have an ML task of predicting your sales, right? And you're just applying a simple multiple linear regression model. I'm not even talking about any deep learning model or any CNN, just a simple model. And the result that you got was from the prediction that there would be a sale of like 700 units, right? Now, as an end user of the application, I really don't know how I got this sales unit of 700 units, right? Or why was this happening? So here comes, or we can apply a SHARP framework to understand how the model arrived at those predictive values, right? So there's a lot of maths behind it, but right now I know it's the overload of all the jargons, all the information right now. Just understand one thing. Understanding the importance of features is the work of SHARP, right? So each feature would be having or given a certain score, right? And in order to find which feature was the best, you would be assigning or you would be making the subset of all the features, gain the probability out of it, and then you get some results, right? I do want to go into the depth. I know I have passed my 20 minutes, so I'll not go more. So I'll just a minute. So I just want to read one definition with you. I know it's quite technical. If you can grasp it, I'm not discussing the big example here. I can share my slides. You can read it. We can discuss afterwards. But when I say sharply values, what does it mean? To find the importance of each and every feature that we are getting for an explanation, we calculate a value for each feature that is called as a sharply value, right? So for each feature that is affecting your output, we calculate a value called as a sharply value, right? So what exactly this term means? This means we arrive at the average marginal contribution of a specific feature acquired using the various possible collations, right? So when I'm using the various possible collations, that means the different subsets of the features, right? When I'm using the marginal contribution, this would mean the distribution probability over the random variables, right? So whenever you're reading any definition, be it ML or everything, what my concept is just to take out the big terms, grasp the meaning of it, and you can understand even the formula afterwards, right? So if you read this definition twice, if you are interested in working in SHAP, look at the mathematical formula for it, you would understand it, right? So for example, I took 5 features for the scenario I was discussing with you for the sales prediction. For example, out of first feature, there was one feature called as the discount rate, right? And there were 4 other features called as the stock, free delivery and price, right? Now I wanted to find out how important the discount rate as a feature was for me, right? So I made these different collations and I found out how important each feature or the combination or the subset of each feature was over the probability distribution, right? So this is just a basic understanding of SHAP. To get to know more about it, you really need to get into that mathematical aspects. I really need a blackboard to explain it. So maybe in the next talk, I can go into more details about it. So this method, mostly people use it for image data set and people use it for your text data set and the tabular data set. Although SHAP and other method that I discussed or just gave a full form was LIME, these are too popular. These people use it for the time series data set, but they are not appropriate XAI methods for the time series data set, right? So people working with image, text and the tabular data can definitely work with this explainable AI method, right? So that's all for today from my side. I just hope you have a basic knowledge of explainable AI now.